Hello, welcome to COP 4708. In this session, we will continue with the relational model, and after we found the entities, define the entities, their attributes and keys, we will address dependencies. As stated before, an attribute that determines other attributes in the relation is called determinant. When a value of one or more attributes can determine a set of other attributes, we call this as functional dependency. For example, in this case, if I have student ID, that can determine student name, or it can determine the dorm name and dorm room and the fees, which means that student ID can be considered as determinant. Although functional dependencies are not equations but could result from an equation. For example, with the extended price, that's equal quantity times unit price, then I can consider having the two attributes of quantity and unit price as composite determinant can determines the extended price. So in this case, the quantity plus the unit price is considered as determinant. And since we are using two attributes, we call it composite determinant. Composite determinant. And again, we would like to emphasize that functions or functional dependencies are not equations. So if you look at this example, we will notice that object color is a determinant that can determine the weight and the shape. And as we stated before, there are not equations, but is used to represent the dependency of an attribute over the other. So this object color can determine other attributes such as the weight and the shape. Some of these determinants can be composite, which means that they consist of more than one attribute. For example, and that's another example that will also guide us through that, which is the student name and class name that can be used as a determinant to determine the student grade. The determinant will be converted into a primary key, which takes us back to the fact that primary keys could be either single or composite. Having a composite determinant means the primary key could be composite. Having a single attribute for determinant means that once I define the primary key, then it will be single. Those functional dependencies follows certain rules. For example, if A can determine B and C, then A can determine B alone and A can determine C alone. For example, if your social security number can determine your first name and last name, then just by knowing your social security number, I can determine your first name by itself, or I can determine your last name by itself. If A and B are needed, both of them, to determine C, then neither A by itself nor B by itself can determine C. For example, the quantity and the unit price are both needed to determine the extended price. If I have the unit price only, I will not be able to define or determine the extended price without the quantity. And if I have the quantity only, I will not be able to determine the extended price without the unit price. Let's look at the following example. This table shown here represents water, sport, and camping items in a retail store. The table includes the stock keeping unit number, the description of the item, and the buyers of those items and the different departments. We need to identify the determinant in this table, then write the functional dependencies. So we look at the table and we search for which attribute could determine the other attributes. And based on that, we can identify the determinant, then create the different functional dependencies. Just by looking at the table, we can say that the SKU is a determinant and can determine the item description, the SKU description, the department, and the buyer. The item description can determine the SKU, department, and buyer. The description will have information enough to determine these attributes. The buyer can determine department, but it will not be considered as a strong determinant in this case, since the buyer can change behavior and buy from another department. From what has been discussed, the SKU as a determinant or attribute, it includes numbers and it's unique. Then it can be converted or can be defined later on as a primary key for this table. So the determinant itself is the primary key, is my primary key that I will use later on in that table. Primary keys, foreign keys, are very, very important in the relationship or in establishing or creating the different tables later on in the database. So we have to understand which one is my primary key, which one can be considered as a primary key. This is very important in designing, in developing, and in implementing database and database management. It's very important to understand which number I can use or which attribute I can use to define or to pull the data from the other attributes or from the other columns. The SKU description in this case, although it is a determinant, but can be considered as a candidate key, while buyer will not be considered as a candidate key due to the possibility of redundancy. So we have to know which determinant to use as my primary key. Let's look at another example. In this table, we have the order, all the orders that is related to the different items in the SKU table. We have the quantity, the price, and the extended price. Now we need to identify the functional dependencies in this table. The order number with the SKU can be used as a composite determinant to determine the quantity, price, and the extended price. We can also use the order number to determine the item that has been bought and their cost. In this case, the order number can be converted into primary key, while we can use the SKU as the foreign key coming from a second table or a second relation. The other determinant that we can recognize is the quantity price composite determinant, which can determine the extended price in this case. Now the question, can I convert that into a primary key for the order item table, and why not? If you look at the quantity price, it can determine only the extended price. but it will not be able to determine the SKU or any other information like the order number. That's why in this case this will not be used. The quantity price cannot be used as a primary key later on. And again, although we can define many determinants in this case, but one of them will be my candidate or my good candidate to be the primary key, while others can be eliminated and will not be used as a primary key. Let's look at the two tables using what we understood from the functional dependencies. We will rewrite the tables with all attributes between brackets, then define the determinant as primary key by underlining the that primary key or that attribute. So the first one will be the SKU data, and my primary key will be the SKU. That's why I underline it here. And then I know that this primary key will determine other attributes within this table. And the same applies for the second table where we have order item. Then I have order number as my primary key. That's why it's underlined. And then I have the other attributes. Now the question, why did I underline the SKU table in the second one? To create the relationship between the two tables, the SKU attribute has been used in both tables. The SKU table or attribute, the SKU attribute in the first table is used as a primary key, while in the second one is used as a foreign key. So it's primary key here, but it's foreign key here. And that's why, or that's how we create the relationship between the two tables. So now I have a relationship between the two tables, and when I pull the SKU for in the order item, it will give me the description, department, and buyer information from the SKU table. But we have one problem here. What if the numbers here did not match the numbers here? And this is what we called before a referential integrity constraint. So we have to add a constraint that will make sure for me that integrity exists when I refer or when I have a reference of an attribute in one table from another table. What will be the statement in this case? The statement will be where, so I'm saying that this is a condition, order item.sku, that means the attribute that's called SKU in the order item must exist in the SKU attribute in the SKU data table. So this statement enforces the referential integrity constraint. Let's look at another example. We have department, and in the department table we have department name, budget code, manager name. In this case, the department name was a unique attribute and could determine other attributes. So this one will be my determinant. The department name as a determinant can determine budget code and manager name. The department name will be used as my primary key. That's why I underline that attribute to represent my primary key. The second table is the employee table, and the employee table has attributes employee number, employee name, and department name. Based on that, I can identify the employee number as my determinant. So my determinant is employee number, and it can determine other attributes such as employee name and department name. Based on that, it could be a primary key, and I can underline it. To connect the two tables together, I have to use one of these determinants in the other table, and I will choose to add to the employee table department name. If I choose to do that and italicize it, then with the underlining and being italic, it will mean that this is a foreign key that will connect the employee table with the department table. So I have a primary key and a foreign key. In some situations, it's very hard to find determinant that is unique and can determine all the attributes in the table. At that point, we can add unique numeric attribute that can be used as a primary key. This type of key is called surrogate key. A surrogate key is a primary key that has been added to determine other attributes in the table. So in this example, if you look at the rental property table, you will see that it has street, city, state, zip code, country, rental rate. And none of these can be used as a unique determinant that can determine other information. In this case, I will add the surrogate key that's called property ID, and then we will have property ID as a determinant and as a primary key that can determine the other attributes in the table. And this was a link between what we learned in the keys lecture and what we learned in the functional dependencies lecture. That will be all for this session. If you have any questions, you can either email it or you can use any communication channel as stated in the syllabus. Thank you and have a great day.